Radon!
What is radon? Radon is a rare radioactive gas discovered by Frederick Dorn in 1898. Radon belongs to the noble gas family. It is located in period 6, group 18, and has an atomic mass of 222. The atomic number is 86, which means that radon has 86 protons and 86 electrons. To find the number of neutrons, we simply subtract atomic number from the atomic mass, which gives us 134. So we have 134 neutrons. Physical properties of radon is that it is colorless, odorless, and tasteless. Only colorless at room temperature of 20 degrees Celsius and standard pressure of 101.3 kilopascals. But when radon reaches its freezing point of minus 71 degrees Celsius, alpha and beta particles and gamma rays literally bombard the radon particles, causing them to glow a yellow color. As the temperature lowers, the color turns into red and orange. Also, the boiling point of radon is 62 degrees Celsius, negative 62 degrees.
Radon has 35 known isotopes. Many of these isotopes have a half-life of just a few seconds. For example, radon-195 has a half-life of just 6 milliseconds. There are only 4 known naturally occurring isotopes of radon on Earth. The rest have been created in lab environments. Also, radon-222 is known to be the most stable, having a half-life of 3.8 days.
This leads to our next topic of all the things that can be released from a radioactive element. There is a alpha particle, a beta particle, and gamma rays. The alpha particle is composed of 2 protons and 2 neutrons, which is equivalent of 1 helium nucleus. And beta particles are made up of just fast-moving electrons that leave the radioactive element.
Chart for uranium-238, which is one of the Earth's most common radioactive elements. Uranium's half-life is 4.5 billion years, which means half of it will decay in that amount of time, and in the process release a lot of energy in the form of alpha and beta particles, and it will also create a new element.
This is an example from the uranium decay chart that was previously shown. As you can see, radium is decayed into radon while releasing an alpha particle. And if you remember from before, an alpha particle is made up of 4 AMUs because it has 2 protons and 2 neutrons. And then, if you look at the atomic mass of radium, it's 226. But then when it decays into radon, it turns into 222. So when it decays, 4 AMUs are subtracted, which is the alpha particle. This is another example from the uranium decay chart. In this example, the element lead turns into bismuth. But as you can see, 214 and 214, so the atomic masses stay the same. But how can atomic mass stay the same if one element turns into another element? In order for an element to turn into another element, the proton number must change. So we can conclude from this that even if the atomic mass stays the same, the proton number differs. This is possible because a proton and an electron makes a neutron. So when the electron, the decay of the radioactive element, leaves, the neutron turns into a proton.
Looking back at the uranium decay chart, all the elements underneath are actually more likely to cause cancer than the elements above radon. This is the case because the elements under radon have shorter half-lives, so there are more frequent alpha and beta particle releases. The alpha and beta particle emissions are what cause damage to DNA, which ultimately leads to cancer.
Breathing in radon causes it to decay in lungs, so it causes lung cancer. The only known health effect in humans is an increased chance of developing lung cancer. Radon exposure has been a pretty big dilemma in our everyday lives, as it has been known to be found in basements. The basement case only represents a problem of our everyday lives, but there are also cases where this dangerous element has contributed to worldwide events. Such an example is the Chernobyl nuclear plant explosion. When the reactor exploded from overheating, it spewed tons and tons of radioactive material that can decay into radon. To this day, the walls in Chernobyl leaked radon particles. The city is so radioactive that animals and plant species have mutated in ways never discovered before. Other than that, the city looks like a total post-apocalyptic world. Here is a video of Chernobyl. To summarize radon, we went over chemical properties, physical properties, decay particles, which were alpha, beta, and gamma rays, the basement radon leaks, health effects, and a worldwide effect, which is Chernobyl.
Particle gets released.